I'd like to find the exact value of the cosine of 5 pi over 12. This is not a unit circle value. It is not a familiar one. It's not one of the ones that we know or that we can look up easily. So what are we talking about an exact value here? Well, there's an identity for that. First thing we're going to try and do is rewrite 5 pi over 12 as a sum or difference of two angles that we do know about. There are several ways to do this. I'm going to pick this one. The cosine of 5 pi over 12 is the same as, well, let's see, 5 is 9 minus 4, so I could say that's 9 pi over 12 minus 4 pi over 12. There's one way. And notice this still says cosine 5 pi over 12. It almost does. It just does it in a different way there. Now it does. But 9 pi over 12, we have a better name for that we can simplify that. 9 pi over 12, I would call that 3 pi over 4. And 4 pi over 12, 4/12 is 1/3. So this still says cosine of 5 pi over 12. But now it says it in such a way that I'm going to actually be able to find an exact value because I know exact values for sines and cosines of 3 pi over 4 and pi over 3. The identity is the sum and difference identity for a cosine, and that looks like this. Cosine of the difference of two angles is cosine of the first, cosine of the second. For the cosine, I'm going to put the opposite of whatever's there in between, so that'll be plus. Sine of the first, sine of the second. For our purposes here, the role of alpha is being played by 3 pi over 4, and the role of beta is being played by pi over 3. So let's fill in here. Let's see, I'm going to have cosine, cosine, sine, sine, with plus in between, and we're going to fill in the blanks. Cosine of alpha. Alpha is 3 pi over 4. Sine of alpha is right here, 3 pi over 4. And then cosine of beta. Beta is pi over 3. Sine of beta. Beta is still pi over 3. Once we get to here, this just becomes a unit circle question. We're going to look up those values, or hopefully we're starting to remember those values without having to look them up. Cosine 3 pi over 4. 3 pi over 4 is in quadrant 2. My cosine values are negative in quadrant 2, so I got negative root 2 over 2. Cosine pi over 3. Well, pi over 3 is in quadrant 1, so that's positive, a half. And then sine 3 pi over 4, well, sine values are still positive in quadrant 2, so that's positive root 2 over 2. And sine of pi over 3 is root 3 over 2. We're going to multiply, we're going to add. My denominator is 4 on both sides, that's nice. And then numerators, let's see, I have minus root 2 and plus root 6. So I'm going to write that like this. Positive root 6 minus root 2. Denominator is 4. And there it is. That's the exact value of cosine 5 pi over 12. Now if you looked at that and said 5 pi over 12, that's 2 pi over 3 plus, or 2 pi over 12 plus 3 pi over 12. That's true. And if you used cosine of 2 pi over 12 plus 3 pi over 12 instead, guess what? You're going to get the same thing. And that's totally fine. However you see it best, that's what you should pick.